Hi everyone, and welcome to the Cybersecurity Sauna. My name is Janne Kauhanen, and I will be your sauna majuri and the host of this podcast. Thank you for joining us for another session where we sweat out the hot topics in security. Welcome to all listeners, and be sure to follow us on Twitter at Cybersauna. The topic of application security has never been more important. How are companies approaching AppSec? What should companies do to ensure AppSec gets the attention it needs? Today, Antti Tuomi, who works in Japan, and Antti Vaha-Sipila, also known as AVS, not to be confused with AWS, from Finland, are joining us to share their thoughts on the current state of AppSec. So guys, throughout your career, what have you seen change in terms of how application security is regarded by our organizations and how they tend to approach that?
Well, at least for me, the one interesting trend that I've seen is the rise of threat modeling. 10 years ago, if you looked at how companies were doing security, very, very few companies said that they do threat modeling, which is essentially just like thinking about risk beforehand, before starting implementation, right? But now it's not rare at all. For example, we help a lot of people with threat modeling, getting the kind of wheels off the ground. So it's not rare anymore.
I think it's kind of interesting also speaking about this with AVS here, because you have a lot of experience in enabling security in development as part of a development organization. Whereas during my history in security, I have mostly been on the security auditing, security testing side of things. There has been a lot of change like on both sides of that spectrum. Like when I was starting in the application security industry or business, like back in the late 2000s, usually we would do a security test as ordered by the customer, and then we would find some vulnerabilities. And, that would be the norm back in the day. So, of course, cross-site scripting, SQL injections, all those things were reasonably new. And usually when we held the meeting about, okay, here are the results, usually the first thing would be like, well, is this really an issue? I mean, we have SSL. So does it matter if we have these scriptings and these injections? Our database server is in the intranet. You can't access it. This isn't exploitable, is it? So we had to, go through that whole process of like, okay, which part in the security stack takes care of actually which layer of security? And that is definitely, fortunately, one of the things that I do not remember having to have that discussion in the last 10 years now. So I'm very happy about that.
This must have been around the same time when somebody asked me that if SQL injections are a thing, why are people still using SQL? So, do you feel that companies are more aware of what these security sort of basics mean now that we're having less of those conversations?
Definitely. I think the overall security awareness, security not just being, antivirus and firewalls, but also being how you build the applications. That is now a common piece of common sense that, yes, we do need to also protect our applications, not just the networks and the endpoints.
Right. Antti-san, when you say that you haven't seen that sort of stuff for a while now, do you think that the root cause is just about awareness, or is it about frameworks and architectures getting safer or something like that?
That's actually a very good point. And I think you are absolutely correct in hinting that frameworks and everything do have a big part in that. Because if you consider, for example, the web application development languages and frameworks in late 2000s, early 2010s, you would still have a lot of applications written in PHP, just vanilla PHP. And if you didn't know that SQL injections are an issue, then how would you prevent them? And nowadays, a modern MVC framework with ORM layer on top of it, it is actually more difficult to write an injection flaw than it is to write a normal safe query. So yes. I think you're definitely right about that.
The reason I asked was because the other big trend or big change that I'm seeing is really, especially in greenfield development, when you're doing something new, something completely new, the architecture nowadays tends to be like a cloud native architecture. So we see a lot of APIs, even a microservice architecture. And I think that does carry a significant security benefit, because APIs are much more restricted in what they can accept. For example, you don't have to do that sort of page building on server side anymore and so on. So I think that is the major contributor from my perspective to this situation.
So do these frameworks and new methods of working, do these mean that, we're actually making software secure by design more easily than before?
Not necessarily by design, but the basic layers and premises of security are often abstracted away so that the average developer does not have to think like, okay, with my MVC framework and ORM framework in 2021, how do I write an SQL query? What type of a join do I need to make? Instead, you just, query for objects in the code and you just get it. So it's completely, you don't need to touch the internals.
Right.
And that definitely helps in also making sure that you don't touch the internals in the wrong way.
Yeah. And if you spread your architecture in a microservice way, for example, the database might be owned by one single microservice that only does its thing. It doesn't do anything more complicated than respond to well-formed queries over HTTP and JSON. Even if somebody would compromise your application, they wouldn't be able to, for example, escalate their access to the database that would reside on the same box, for example. So in a way, it is like security through design, but I think that security is one of the many side effects of the new design. It's not necessarily the thing why things had been designed in that way.
Okay, so you think there's still ways to go for companies before they're in that fully sort of secure by design mode?
Definitely.
You could say that now that we have this sort of a robust architecture, then this is what we mean by security by design, and then you could,
okay.
I don't know. I mean, you could just paint it white and call it white.
Fair enough.
One of the things that I find intriguing is that, in the late 2000s, OWASP Top 10 was kind of a reasonably new thing, right? If I remember correctly, the first edition came out in 2004, I think, and the next one in 2007. And one of the kind of interesting things about the change or the lack of change is that OWASP Top 10 is still quite relevant. I think especially over here in Japan, and I think also in Europe as well, we still very often get requests like, could you test whether our application has any OWASP Top 10 vulnerabilities? So although the standard is there and it has changed a bit, but the basic premises are still there, and there's a lot of still very similar or the same vulnerability categories. It's still one of the base resources. Like, do we have OWASP Top 10? That's what we want to know.
A couple of years ago, there was a stat in a Black Hat presentation. I saw that 1 in 5 developers have never heard of OWASP Top 10. Is that your experience with developers these days and their sort of level of security knowledge?
I would have to say that at least based on my experience in Europe, I would say that most developers were already familiar with OWASP Top 10, like in the 2010s and going forward. And I do not remember having to introduce OWASP Top 10 to anyone within the last 10 years. And at the moment, over here in Japan as well, it seems to be a very well-known basis for application security. But at the same time, I do also find that there's a lot of cases where the customers focus so much on the OWASP Top 10 that they forget everything beyond it. For example, XML external entities were not necessarily directly a part of the OWASP categories, at least not at all times. And in many cases, they might forget that, that's actually something we need to look for. So there's more to it than just the OWASP Top 10.
OWASP Top 10 is a very wide generalization. I mean, everybody,
Absolutely.
Every single company has a slightly different top 10 if you really look at the types of vulnerabilities that they have. When I started at a software company as a AppSec person in 2011, the first thing I did was I just got all the reports from the past 3 years and went through them, and security testing reports, and just categorized all the findings and tried to figure out what's the type of a flaw or a bug that we are seeing in that company. And I've got to admit, it was really not OWASP Top 10. For example, database injections were not a thing at all, mostly due to the architecture that they had adopted.
So you're saying the top 10 for a bank might not be the top 10 for an IT service provider?
Well, definitely not. And it even within the vertical, it depends on the company and the type of architecture, type of software stack that they've chosen. I mean, if you are going to do like old school PHP, you are more vulnerable to types of things than if you're using a very mature framework, right? So I don't know if it matters that much that the developers definitely have to know OWASP top 10. They have to know what are the specific risks for their type of architecture and stack.
Sure. I mean, if you know the exact situation in your organization, you're always going to be better off. But like if you have no starting point at all, I would argue that the OWASP top 10 is better than nothing. Like that's like if you don't have that company specific information, start from this.
I mean, OWASP is well known, but AVS, have you seen or heard of any other like upcoming resources that especially like security aware companies refer to nowadays in Europe?
Those companies that are looking to integrate security earlier on in the drug development process, many of them talk about the software maturity models. Like one is from OWASP SAM. The current version is not that bad anymore. And there's the BSIM model from Synopsys, Digital, which is probably more well known. I think that those are the things that companies would actually mention nowadays. When talking about this.
That's interesting. One of the topics that often nowadays comes up when we talk to these modern application developers and who are, running on, for example, AWS cloud infrastructure and running like full DevOps cycles. One of the things that we often get asked is like, okay, is there something we need to do to secure our DevOps pipeline? So I'm kind of wondering, like, when are we going to get the, not the OWASP top 10, but the DevOps top 10? List of things you should be doing or should not be doing?
I'm going to guess that already exists in at least 3 different companies' marketing material. I mean, that sounds like something that you'd do if you'd have a tool. I mean,
yeah, that makes sense. But like, OWASP is still like the most widely known out there, and the new top 10 list is out this year. Some changes in there. What do you guys think about new items on the list? My particular favorite is insecure design.
Yeah, speaking about tools, I mean, OWASP top 10's been used a lot for like classifying findings from automated tools. So good luck automating that one.
Yeah.
Definitely. And although like I definitely think that category like belongs there, like insecure design, for example, like for a very concrete example, maybe for example, if you expose your internal VPCs in your AWS cloud infrastructure, you expose, for example, S3 buckets to external users, that might be like insecure design or insecure configuration. So, it definitely does belong on the list, but the instructions on, okay, how do you check for this? How do you assess this? How do you fix this? Well, design it better.
Yeah, so it's a bit of a catch-all category, and the main reason for security mistakes is that people make security mistakes.
Exactly.
It's very hard to operationalize that thing. So I mean, on the privacy or data protection side of things, there are many checklists. I mean, how to process personal data securely, do this and this and this and this, and then as the last one, hey, remember you have to be compliant to regulation. Why don't you code already?
Yeah, exactly.
So it's like
Yeah. So, okay. So, what kind of issues are you guys then finding most when you're looking at applications? What's your personal top 10?
I think kind of a pattern that has been continuing for me for maybe the last, 5 years or so, since 2015, is that technical vulnerabilities are getting harder and harder to find, especially when it comes to the traditional like cross-site scripting and SQL injection types of things. And that is likely very much also due to the frameworks in place. But one trend, at least that I personally think still applies, is that issues related to access controls, for example, being able to see other users' data or being able to change some parameters in a like an API request, just being able to access a feature or data that you should not be able to. Those are still reasonably common. And of course, also those so-called business logic vulnerabilities where, you skip a step or you skip the payment altogether and still get the product. And, these kinds of utilizing the flow of the application in an unexpected way are still fairly common. On the other hand, what's kind of interesting, I think, is like, what are the types of issues that development organizations are struggling with when it comes to these like application infrastructures? What types of threats catch the developers and the product owners off guard?
Yeah. I'd say that supply chain issues are really a big thing. If you're doing threat modeling, you tend to find more like architectural and design level issues, not like implementation level issues, unless you're doing like retroactive threat modeling. In this case, you can actually find bugs. But typical pattern maybe for a finding could be that you have a assumption that a component works in a certain way or comes from a trusted source, when in fact it doesn't come from a trusted source and it doesn't exactly work in the way that people assumed it would work. That causes security issue or a potential weakness at least.
I guess you're talking about, for example, these dependency confusion attacks. And
that is one type of it, yes. Then maybe like also if you call an API, what sort of assumption it makes for the inputs. Can you really trust the data that it's sending back? Because, for example, it might be that you are the first one to actually having to validate the data you get from an as a response, even though it is coming from your internal API. But maybe it might be that nobody else has actually validated the data before you. So things like this. Very rarely we'd have to touch the types of technical vulnerabilities that are mostly in OWASP Top 10. But now that OWASP Top 10 has this design level thing, then it's obviously we can claim that we are also doing OWASP Top 10 stuff.
We were already touching on sort of automating OWASP Top 10 testing or whatever, and that's certainly a trend I think I'm seeing in the industry towards sort of the commoditization and automation of application testing rather than sort of human crafting a test for per solution. Do you think that's happening, and do you think that there is a concern that, like, I would think that a machine is not going to be as adaptable as a human being. So is that going to be an issue?
There's a couple of very interesting like cultural or regional anecdotes I have about that. So when it comes to the Japanese culture and the definition of quality, what's expected of tests, including security tests, is that they are well defined, repeatable, and kind of defined beforehand. So that's actually something that's often kind of expected from security testers like us as well. And basically the ultimate goal, if you are able to define those tests, like have well-defined test cases and all that, then in that case the test should be automatable as well. And I think that's actually that's a very good thing to aim for, in the sense that all the tests that we can automate, we should be automating, because then it's repeatable. We don't, there's a lower chance of making a mistake when performing it and all that. However, at the same time, I do think that security is also about exceptions. And when it comes to like exceptions to the rule, there's an like innumerable number of test cases we would have to perform to cover all test cases. And in order to, first of all, define like, okay, how do we test for insecure design? How do we define a, well-defined set of test cases for that? Well, it's not going to happen. And in that sense, like, the strive for automation is very good, but I do still think we need this explorative testing and, expert review type of work as well.
Antti, we discussed like the other day about maybe the cultural differences on where companies assume that exploratory security testing should be taking place. And that's an interesting thing.
Definitely. When companies are asking us for a quote for like security testing over here in Japan, and we usually say that, okay, we will do also like testing for business logic vulnerabilities and access rights and so on. And some of the customers are surprised because they don't see that as part of security per se. Instead, that is part of like exploratory testing to be kind of like, that's on the responsibility of the quality assurance team to verify. So
like it should be, I guess, in some sort of an ideal world.
Yeah. And I think you're actually right about that. So in some customers do think that, security is about the technical security issues and technical configurations, whereas all the access rights and features and explorative testing should be a quality assurance thing. And like you said, in an ideal world, that should be the case. But that's a very interesting cultural difference that I've found, being here for the last 5 years.
Yeah, I wanted to hear that story because the crystal ball is hazy, but I have a feeling security testing will have to diverge a bit to the automated fast testing that you need to do in a CI/CD pipeline, for example, and towards the exploratory business logic type of testing. And if you really think about it, if you have a QA organization that can actually plausibly do that sort of testing, it would be a great thing to do it right there because they have the most understanding of the business logic of the software anyway. So, for example, in threat modeling, for those companies who have exploratory QA, those people are almost always the best ones to find esoteric risks in the system.
And I would definitely welcome that as well, because let's say compared to the situation where we as security testers would go in and, do threat modeling on our own and come up with these attack scenarios, part of them related to the logic, part of them related to the technology. Then if I was able to start testing on an application where I could have a session with the QA team, and they go okay, in threat modeling, we identified that it would be bad if you could, for example, skip this step in the payment process, or if you could access this information. And we already tried all of these and these tricks. And that would be super valuable information for me as well, where I could just basically corroborate their, results as well, and maybe add some technical ways with which you could also try doing these explorative test cases that they came up with. I would be super happy about that.
And also the QA people typically know about the regulatory requirements, maybe better than usually developers do know about the most common ones as well. But I mean, for a specific type of a company, a QA team might actually have more acute knowledge of what it actually takes to be compliant with something. So they could see the knock-on effect of a security bug, how it affects the compliance status.
Like AVS, you have also done, I've also performed a couple of workshops on threat modeling for development organizations. And I do have to say that often the development teams and developers have very good technical input, okay, what if this, this API message, what if the contents are changed, or what if, our implementation is wrong. But it is often, one of the older QA dudes who, when you kind of start going through the threat modeling, with a bit of a couple of examples, then you prompt them, could you come up with something that could go wrong? And those guys are often the ones that, when they get the chance to kind of get going, they just keep on pushing out these really good threat scenarios that nobody else, not the technical peoples, could even think of. And that's always a very, very nice moment when it happens during threat modeling, whether it's a training or actual session.
Yeah. So back to Janne's original question on test automation.
Thank you.
And I think that there is actually a trend now that because if you have a continuous delivery, so essentially code is being deployed into production automatically after it's complete, then that kind of implies you also have to have continuous testing. There's a buzzword that's being thrown around for a while called guardrails. So you build kind of a funnel that is kind of flanked on both sides with the guardrails. So this is kind of trying to convey the idea that you are moving with great speed. So you have such a high velocity that in order to keep you in the pipeline, you need to build guardrails that keep you going straight. If you are moving really fast, if you have high velocity when developing and you need to be deploying to production all the time, continuously, the idea being that if you make a mistake, automation has to catch it so that you don't break your production environment, for example. For example, the cloud environment is going to be defined by some Terraform code. So it's basically one commit away from breaking your whole production environment. So you have to have sanity checks. You have to have some sort of security checks in there. And I think that the focus of automated testing would be moving into that direction, in like medium term. So that there is need for that sort of a tooling that can make sanity checks and catch the most of the low-hanging fruit, so to speak.
Definitely. And if we rule out the purely application level vulnerabilities, I think the second like very large category of vulnerabilities that I've personally witnessed recently is vulnerabilities that are caused by misconfiguration of your infrastructure as a service cloud platform. So all those exposed buckets or other types of issues. I remember recently seeing an article about automated tooling for finding these kinds of configuration issues and vulnerabilities in an automatic way in infrastructure as a code deployments as well.
It seems to me that there are these new security actions coming up, but also that some of the old things that we used to be doing in security and software is now, finding different places in the life cycle than it used to hold before.
I think you're correct, especially in the sense that, for example, antivirus or firewalls, they're not gone either. They're still there, but we have grown so used to them that it's kind of like, second nature or it comes quite granted to us that we need to be paying attention to those. And I think a lot of the other like application security tasks also have become more kind of, common knowledge and, something that we are now used to doing. So definitely they are still there, but instead of testing at the end of the release cycle, we're now maybe doing it slightly earlier. And I think AVS, you had a good term for this, testing at the end of
testing at the testing at the end of the cycle. I called it the kind of level boss testing.
Yeah. So.
If you remember the old shoot 'em up games where there was this large enemy at the end of a level, and you had to clear that before you could move forward.
Yeah, raid boss, level boss. So it's a security test, and if you fail and your party wipes, then you're back in the development phase and need to go back and collect the souls that you dropped.
Exactly.
You guys are talking about a trend that's generally called shifting left of the security. What do we mean by that?
It may mean a bit different thing for different companies, especially, if you are very if you're geared towards DevSecOps, it might mean that you kind of add a bit of tooling before deployment, which means that each time you deploy, you get to do some testing before it gets to that end of level boss fight, so to speak. But you can also think about so it's left means left on the time axis, basically. Right. And you can go even farther left. So if you do threat modeling, for example, before you do design, then that is even one step farther left. And then you can go even more left if you consider, for example, product management. And when you're considering the epics or the business value increments that you're going to work on. If you do some security work there, then that's kind of as far left as you can get time-wise. And you have a spectrum of leftism that you can apply in your organization, I guess.
There we go. So you're moving security to the earlier parts of the software design or software development lifecycle.
Yeah.
I think this adding automation or adding security related test cases to the testing or maybe even threat modeling are things that many of us might be familiar with, but could you give some examples on how can you affect security at the product design or like business decisions phase?
Well, I think that the privacy or data protection, it's a good source for good examples where it actually matters, where you can actually do things early on. If you need to figure out whether your application is going to be compliant with whatever regulations or laws you have to follow, that discussion probably should happen, or it better happen early on, because if you spend time building that, then you find out that you're actually built an illegal application, then that's not a good place to be, right?
Right.
So at that point, you could extend that discussion. If, for example, if you're doing a privacy impact assessment or a data protection impact assessment, as mandated by GDPR or something like that, you could add on to that some initial design discussions. And just one thing that I've seen in real life is that you got some legacy backend that holds onto your personal data. And you have to index the people in that database in some way. And for example, here in Finland, it's very typical to use a social security number, or we call it the personal ID number, to do that. But it's a unique identifier, but it's not random. And the problem is, if it leaks, it's not a good thing, because you can use it to index the same person over a vast array of other services as well. So, for example, a design decision that legacy backend will be also changed to introduce a application-specific, unique random identifier that you could use in this context. So in this case, you can kind of get rid of using that personal ID number for indexing altogether, but that requires changes not only to your new application, but also to the legacy application. And because of the lead times involved, it would be a much better thing if this would be raised already, like in the business discussions when discussing about this feature.
So kind of like, a bit of foresight in security architecture can save you a lot of trouble going forward.
Yes. So it is, in this case, this is kind of an information architecture level decision, almost so.
Well, that makes sense to me, and but it seems to me like let's just shift security left is easier said than done. Is that the case, or are organizations managing this pretty well?
It depends on the culture, really. It might be that security function wants to pull security farther left on the timeline, but the product development organization would also need to want to play ball. In many companies, a security function is still somewhat like separate from the product development organization. Usually a security function is something that has been grown out of the IT security function, and IT being kind of support function to begin with. So you would have to get the buy-in from the product management organization in order to be really effective in getting that pull towards the left. I know that many companies started from the very end of the deployment pipeline, for example, and start the kind of left-leaning activities right there by introducing automation and stuff, because that can be done by maybe a kind of maybe the development teams themselves or a platform support team that provides like common tools for everybody, and that doesn't require like that much organizational renewal.
Yeah, there's a couple of actually, now that you mention it, a couple of quite interesting cultural aspects over here as well. So one of the things that I have personally seen as one of the biggest drivers for, shifting left when it comes to application security, maybe the biggest driver, both in a good and a bad sense, is the timeline of deploying or publishing an application. So in order to avoid, wiping at the level boss, and having to go back to the drawing board and, make the decision of either like publishing a vulnerable application or having to shift the timeline forward, which is bad for the business. And that decision, or that like looming level boss in the horizon, you can see the signs that, okay, here's a save point. Maybe we should be starting to do something about this. So that looming sense of dread about security having a business impact is a kind of in a way, a healthy and unhealthy driver of trying to do security as early as possible. So I think there's a lot of organizations that have realized that, okay, are there some security tasks that we can do earlier so that we can make sure that we are ready for the deployment on time?
Yeah, that makes perfect sense to me. But do you guys think we're supporting these developers enough in sort of building a secure software, or are we just saying like, in addition to everything else you're doing, better make it secure?
Yes, well, that's something that I kind of feel strongly about, in a sense that what we shouldn't really be doing, we shouldn't just tell the developers that this is how you should behave. I think that the organization requires the incentive and especially time allocation to do things properly. So it's not the developers that would be in my focus. It would be really the product management, product owners, and everybody else who own the resources.
That's very also tied into the other cultural difference that I wanted to point out is that, unfortunately, many Japanese organizations still don't have a dedicated CISO, a security officer, or necessarily a dedicated IT security or security team. So what's common is to have a like security operations center that monitors logs maybe and kind of like, monitors alerts from like IDS devices or endpoint protection and so on. But a all-encompassing team that would be able to advise on, for example, application security does not necessarily exist for many organizations. And instead, the kind of the security requirements and the actions often are actually on the responsibility of the development organization. Not having a security function to rely on is, not necessarily a good thing. But at the same time, often the development organizations might have more say into how and when do they include security in the tasks. So that's an interesting cultural difference. One interesting result from that is also that when security is owned by the development organization, if they have people who are passionate about security, or they have some kind of a spark, or they learned about it and they got interested, then often those people are able to drive security parts of the development process forward. And that often results in very good results, I think.
Yeah, I think many companies that I know, they have this sort of a security champion program where they have like a volunteer, either a developer, sometimes even like a scrum master type of person who then take security seriously, and they want to keep the flame burning. It's interesting that I had a discussion with one senior QA person, and they said they'd be interested in actually extending their remit into doing security testing from like normal QA. Not only because they're interested in security, but because it's also something else to do in a while. I mean, if you've been looking at the same functionalities for a couple of years, it really frees your mind when you get to think about things in an adversarial way, for example.
It's very beneficial for the organization as well, because, having these like external security testers and so on, come in at specific times, and, they bill you for money. So instead, being able to kind of also internally take part in this and get employees interested in security, and maybe, have these champions who have the spark. I think that's a win-win for everyone involved.
Yeah, just look a bit more widely at the people you have in your organization. It doesn't have to be a developer. If it's a Scrum Master who likes to listen to Janne's podcast, that might be just the person you need.
We like those people.
If you are an in-house security person, I think it would be very healthy if you'd have very acute understanding of all the other qualities that software needs to fulfill, for example, performance, cost, and time to implement. A security person who's never done any commercial software development might not have the immediate understanding how difficult it is to make a small change. I mean, it's a 15-minute job, yes, but all the like extra bureaucracy and testing and everything else is going to compound into that. So definitely we should staff like internal security functions, especially with people who have like previous software development experience in some way or another.
Yeah. And it's actually, I think it's also very common for people, let's say technical security enthusiasts or experts to, at the beginning kind of, if they find vulnerabilities, kind of, feel like, oh, this is such a simple mistake. Why did they make this mistake? Whereas the actual reason is that the development team might not have enough time or enough resources, or, they knew the vulnerability was there, but the application was published anyway. There's a lot of these things that are very easy to result in this kind of like adversarial feeling or approach that in reality, just should not be there.
Yeah, you always have to remember that, at least this is my opinion, in most cases, it's much easier to find a security bug than to get the whole thing to work in the first place.
Yes.
And you have to, and for example, I think the job that software developers are doing, it's much harder than the one that I'm doing at the moment.
That's what I always tell clients, that, we have the luxury of always thinking about just security, whereas developers have to focus on like secondary things like functionality and usability and features and stupid things like that.
And okay, does it work on the latest version of Chrome? Okay, good. But does it work on the latest version of Internet Explorer? And what about your LG or Samsung smart TV? Does it work on that one? Now someone is, there's a browser on Xbox. So, can you play web games on your, Xbox browser?
Now, guys, to finish off this conversation, I wanted to ask you, like, in your work with organizations, what's the advice you find yourself giving over and over? Like, what's the one thing you wish people remember about application security?
Well, at least for me, it's easy to answer that one. So almost every single organization that I talk to, I end up preaching the same thing. So security work doesn't happen if it's not given time. And with that, I mean that
that's
it really
a very
has
good point.
It has to have an explicit time allocation. It's not enough to like just stick it on some sort of a definition of done where it's kind of hovering there, or if you just like
there's an architecture diagram and there's like all these lines, and then there's like a completely detached box that says security.
Also includes security.
Remember security on a post-it note on a monitor. That's not going to do it. It has to be an explicit time allocation. And in most organizations, what that means is that security needs to be ticketed on the backlog, just as any other development activities would be ticketed. And then how to get that done, that's not necessarily a straightforward thing because...
Yeah, that would have been my next question.
Because that then requires that buy-in that may stretch back to product management and even further than the immediate product owner. And that's kind of taking those left-leaning steps like much farther than just the CI/CD pipeline, for example. But that's the thing, time allocation.
Should security be an epic on the board, or would you attach security to individual tasks? Or
no, Antti, that's going to be an entire episode in itself. Let's tackle that another day. What's Antti-san? What's your advice for organizations?
That's a really tough question that I don't have a good answer for. It really depends on the organization and the parts that they are struggling with. But what I can say is that I think in my experience, the companies and organizations who embrace security as not just a compliance thing, but more of have found the internal, people who are like willing to advocate for security during the design, during the implementation phases. I think those organizations are the ones that end up having the least problems to fix and end up finding the time and the budget to fix things.
Fair enough. Well, with that, I want to just thank you guys for being on the show today and walking us through the jungle that is AppSec.
Thank you. It's been great.
Thanks, Janne. Thanks, Antti.
That was the show for today. I hope you enjoyed it. Please get in touch with us through Twitter with the hashtag Cybersauna with your feedback, comments, and ideas. Thanks for listening. Be sure to subscribe.